So frequency distribution in statistics provides the information of the number of occurrences or frequency of distinct values distributed within a given period of time or interval in a list, table, or graphical representation. Group and ungroup are two types of frequency distribution. Data is a collection of numbers or values and it must be organized for it to be useful. So let us take a look at data and its frequency distribution. Okay. First, we tackle about data. Data is any bit of information that is expressed in a value or numerical number is data. So basically, it is a collection of information, measurements, or observation. For example, the marks of you scored in your math exam is data, and the number of cars that pass through a bridge in a day is also data. After the very first step of data collection, you will get raw data. Raw data is an initial collection of information. This information has not yet been organized. For example, we go around and ask a group of 5 friends their favorite color. The answers are blue, green, blue, red, and red. So this collection of information is the raw data. Okay. So in the data, we have the discrete data and also the continuous data. Discrete data is that which is recorded in the whole numbers, like the number of children in a school or number of tigers in a zoo. It cannot be in decimal or fractions. So discrete data is information that can only take certain values. Okay, an example is the number of each type of treatment a salon needs to schedule for the week, or the number of children attending a nursery each day, or the profit a business makes each month are all examples of discrete data. This type of data is often represented using tally charts, bar charts, or pie charts. Next is continuous data. Data need not be in whole numbers and can be in decimals. So continuous data is data that can take any value. Example is height, weight, temperature, and length are all examples of continuous data. Now, some continuous data will change over time. The weight of a baby in its first year or the temperature in a room throughout the day. This data is best shown on a line graph or this type of graph can show how the data changes over a given period of time. Other continuous data, such as the heights of a group of children on one particular day, is often grouped into categories to make it easier to interpret. Okay, frequency. So the frequency of any value is the number of times that value appears in a data set. So from the previous examples of colors, we can say that two children like the color blue, so its frequency is 2. So to make meaning of the raw data, we must organize. And finding out the frequency of the data value is how this organization is done. A frequency distribution is a representation, either a graphical or tabular format, that displays the number of observations within a given interval. So the interval size depends on the data being analyzed and the goals of the analyst. The intervals must be mutually exclusive and exhaustive. So, frequency distribution are typically used within a statistical context. Generally, frequency distribution can be associated with the charting of a normal distribution. Okay. So many times it is not easy or feasible to find the frequency of data from a very large data set. So to make sense of the data, we make a frequency table and graphs. So let us take the example of the heights of 10 students in centimeters. This frequency table will help us to make better sense of the data given. Also, when the data is set is too big, say if we were dealing with 100 students, we use tally marks for counting. It makes the task more organized and easy. Okay. So we have here, using the previous example, we can make the following graph. So we have here the frequency distribution graph. Okay. So we have the types of frequency distribution. First, grouped frequency distribution. A grouped frequency distribution is an arrangement class intervals or and corresponding frequencies in a table. Next is ungrouped frequency distribution, is an arrangement of the observed values in ascending order. The ungrouped frequency distribution are those data which are not arranged in groups. They are known as individual series. And next is the cumulative frequency distribution, or CFD. One of the important types of frequency distribution is this cumulative frequency distribution. In here, the frequencies are shown in the cumulative manner. The cumulative frequency for each class interval is the frequency for that class interval added to the preceding cumulative total. Cumulative frequency can also be defined as the sum of all previous frequencies up to the current point. Next is the relative frequency distribution. It's a distribution where we mention relative frequencies against each class interval. Relative frequency of a class is the frequency obtained by dividing frequency by the total frequency. Now, relative frequency is the proportion of the total frequency that is in any given class interval in the frequency distribution. Okay, so we have here an example of a frequency distribution table. We have the lower bound, the upper bound, and the boundaries. We also have the frequency, of course, its relative frequency, and the cumulative frequency distribution. Okay, upper and lower bounds. To describe all the possible values that a rounded number could be, we use lower and upper bounds. Now, if a number or measurement has been rounded, it can be important to consider what possible values the exact value could have been. For example, if a kitchen unit is 600 millimeters wide to the nearest 10 millimeters, it could actually be any width from 595 millimeters up to 605 millimeters. So it might not fit into a gap that is exactly 600 millimeters wide. Now, the lower bound is the smallest value that would round up to the estimated value. The upper bound is the smallest value that would round up to the next estimated value. This can be shown as an error interval using inequality symbols. We have an example. A mass of 70 kilograms rounded to the nearest 10 kilograms has a lower bound of 65 kilograms because 65 kilograms is the smallest mass that rounds to 70 kilograms. The upper bound is 75 kilograms because 75 kilograms is the smallest mass that would round up to 80 kilograms. And this can be shown as an error interval using inequality symbols. 65 kilograms is less than or equal to the weight and less than 75 kilograms. Now, a quick way to calculate upper and lower bounds is to have the degree of accuracy specified, then add this to the rounded value for the upper bound and subtract it from the rounded value for the lower bound. Okay, boundaries. In the frequency distribution, class boundaries are the values that separate the classes. We use the following steps to calculate the class boundaries in a frequency distribution. First, we subtract the upper class limit for the first class from the lower class limit for the second class. Second, divide the result by 2. And third, subtract the result from the lower class limit and add the result to the upper class limit for each class. Okay, we have an example calculating the class boundaries. Okay, so the following examples show how to use these steps in practice to calculate class boundaries in a frequency distribution. Suppose we have the following frequency distribution that represents the number of wins by various basketball teams. Okay, so first we subtract the upper class limit for the first class from the lower class limit for the second class. The upper class limit for the first class is 30 and the lower class limit for the second class is 31. Thus, we get 31 minus 30 that is equal to 1. Second, divide the result by 2. Okay, next we divide the result by 2, so we get 1/2 that is equal to 0.5. Lastly, we subtract 0.5 from the lower class limit and add 0.5 to the upper class limit for each class. We interpret the results as follows. The first class has a lower class boundary of 25.5 and an upper class boundary of 30.5. The second class has a lower class boundary of 30.5 and upper class boundary of 35.5. The third class has a lower class boundary of 35.5 and an upper class boundary of 40.5. Okay. Suppose we have the following frequency distribution. We use the following steps to calculate the class boundaries. Subtract the upper class limit for the first class from the lower class limit for the second class. So the upper class limit for the first class is 60.9 and the lower class limit for the second class is 61. So we get 61 minus 60.9, that is equal to 0.1. Okay, next we divide the result by 2, so we get 0.1 divided by 2, that is equal to 0.05. Lastly, we subtract 0.5 from the lower class limit and add 0.5 to the upper class limit for each class. So we interpret the results as follows. The first class has a lower class boundary of 55.95 and an upper class boundary of 60.95. The second class has a lower class boundary of 60.95 and an upper class boundary of 65.95. The third class has a lower class boundary of 65.95 and an upper class boundary of 70.95. A relative frequency is the ratio or fraction or proportion of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. Okay, so to find the relative frequencies, we divide each frequency by the total number of students in the sample. So in this case, we have 20. So the relative frequency is equal to frequency of the class divided by the total. Okay. Relative frequencies can be written as fractions, percents, or decimals. Okay. It's possible to calculate the relative frequency for each class, which is simply the frequency of each class as a percentage of the whole. In total, there were 66 items sold. Thus, we found the relative frequency of each class by taking the frequency of each class and dividing by the total items sold. For example, there are 20 items sold in the price range of $1 to $10. Thus, the relative frequency of the class $1 to $10 is 20 divided by 66, that is equal to 0.303. Okay, here we have an example of a relative frequencies in Excel. First, we will enter the class and the frequency in columns A and B. Next, we will calculate the relative frequency of each class in column C. So column D shows the formulas we used. We can verify that our calculations are correct by making sure the sum of the relative frequencies adds up to 1. We can also create a relative frequency histogram to visualize the relative frequencies. Simply highlight the relative frequencies, then go to the charts, group in the insert tab, and click the first chart type and insert column or bar chart. Okay. A relative frequency histogram will automatically appear. Modify the x-axis labels by right-clicking the on the chart and clicking Select Data. Under horizontal category axis labels, click Edit and type in the cell range that contains the item prices. Click OK and the new axis labels will automatically appear. Okay. Cumulative frequency distribution. It is the sum of the class and all classes below it in a frequency distribution. All that means is you're adding up a value and all of the values that came before it. Technically, a cumulative frequency distribution is the sum of the class and all classes below it in a frequency distribution. All that means is you're adding up a value and all of the values that came before it. Okay, so here's an example. This table shows the frequency of hair colors for a population sample. If you add up all of the frequencies for what's being asked, you get a total of 41. So we have 15 plus 10 plus 16 that is equal to 41. You can also write this equivalently with summation notation. The sigma just means to add them all up. Okay. So why would you want to use a cumulative frequency distribution? Maybe there are a couple of reasons why do we want to use it. Okay, so first you want to check that your math is correct by adding up all of the numbers and comparing it to your sample size. You know you've included all your data. For example, if your sample size was 44, in this case you'd know by the cumulative frequency distribution that you're missing one piece of data. Number two, you're interested in studying a population to find out a more or less question. For example, you're thinking of opening a bargain grocery store and you want to know how many people in a particular geographic area spend up to $6,000 per person per year in groceries. So the right column will tell you that 614 people spend up to 6,000 per year. It includes everyone who spends up to $6,000. Okay. A cumulative frequency doesn't have to just include everything less than something. In the table, you could also start the cumulative distribution from the bottom. Let's say you were the manager of a premium grocery store and you wanted to know how many people spend more than um $5,000 in groceries. Your your cumulative distribution would look like this. Tells you that 394 people spend more than that amount per year. Although it's usual to make tables for cumulative data, line graphs can also be used like the frequent like the cumulative frequency polygon.